team. In this video, we're going to look at what is elastic computing and how we achieve it. So elastic computing is what allows cloud tenants to increase or decrease the amount of resources that they lease from public clouds on demand. But how does a cloud provider support this? So cloud providers need two main things. First is they need to allocate resources to customers at fine grains, like small allocations. And to get an example of how this happens, you can look at the size of the virtual machines offered by Amazon or Google. And there are very small virtual machines. For example, the T2.Nano virtual machine on Amazon EC2 has one virtual CPU and 0.5 gigabytes of RAM. So if you think of a server with 256 gigabytes of RAM, this server can run like hundreds of these nano virtual machines. So fine-grained allocations is one thing, and the other thing we need is to relocate resources from one tenant to another seamlessly. If I have 10 virtual machines right now, and then in the next hour I can release 5 of these virtual machines, the capacity that I freed up must be reallocatable to other customers. So if you come along and request 5 virtual machines, you might be located on the same server that I was using before. And then the cloud provider can move customers around as they come and go. Now, of course, allocating physical resources to customers is not going to work. So if a cloud provider had to allocate like a physical server to a customer, then the allocations would be very coarse. You would need to allocate a lot of resources to each customer, and you wouldn't be able to move resources from one customer to another very quickly. So virtualization is a technology that supports virtual machines and containers. And virtualization allows public clouds to make fine-grained allocations and move capacity from one customer to another. So virtual machines and containers have the following properties. First, creation and removal is very fast, and it's fast because it's entirely controlled by software. So running a virtual machine on a server is just like running a program in our computers. You can start the program, close the program, start the program, close the program. So it's just the same with virtual machines on servers, and this starting and stopping of virtual machines is controlled by software. So the physical machine, the server, and the operating system like Linux or Windows running on the server is not impacted in any way when we create or destroy a virtual machine. Another property is that virtualization allows the sharing of resources on a server. So we can run multiple virtual machines or multiple containers on the same physical server. And virtualization also provides isolation between virtual machines and containers. So this means that the virtual machine running on a server does not impact other virtual machines in any way. So if a virtual machine is running a very heavy computation, the other virtual machine runs just as well as if there was nothing else on the server. If a virtual machine is making a lot of disk accesses, the other virtual machine will also not be impacted in any way. So this we call performance isolation, and there's also data isolation. So one virtual machine cannot see or infer what the other virtual machine is doing, much less access the data that the other machine is accessing. So this isolation separates customers even though their virtual machines are running on the same physical server. So let's have a look at each of these in more detail. So virtual machines and containers, their creation and removal are entirely controlled by software. So when we start a virtual machine on the cloud, or when we increase the amount of memory that our virtual machine has, no human action is involved. So it's all software. It's going to reconfigure the virtual machine for us. And the physical servers that run the virtual machines, they rarely need to reboot. Only when you upgrade the kernel or something like that, then you reboot the server. But if there's no software upgrade, the server can just remain running with the virtual machines on top. And you only need to shut down servers if you want to save energy. For example, if there's not a lot of virtual machines on a server, you can move these virtual machines to a different server and then turn that server off to save power. And a single server can host multiple virtual machines, like I said before. And the virtual machines, they can be paused, they can be migrated to a different server, they can be stopped and restarted later on. So there's a lot of flexibility on what we can do with the virtual machines. So if the virtual machine is running on a server and the server crashes for some reason, say there's a disk failure or memory is corrupted, then we can restart this virtual machine on a different server using the last snapshot that we had from that virtual machine. And creating virtual machines takes seconds instead of hours, just like running a program in our computer. So deploying a physical server is, troublesome process. I have to install the operating system, configure everything, and then start running applications on top. Deploying a virtual machine is very fast. It just start the virtual machine, and then it has its own operating system inside, and then the customer is good to go. Isolation provided by virtualization is good for the customers. Like I explained, one virtual machine is not impacted by what other virtual machines are doing, and data doesn't leak from one virtual machine into another. So it's good for customers because it provides performance and data isolation, but it's also very useful for the provider because it means that the provider doesn't need to care where the virtual machine is running because there's isolation. So it can one day put my virtual machine together with customers A virtual machine, and then the next day it might move my virtual machine, and now I'm running with customers B virtual machine, and then it doesn't make any difference for the cloud provider. So this flexibility is also afforded by isolation. So software control and isolation provide a lot of flexibility. For example, the cloud provider can choose where to create virtual machines, and it can, for example, spread virtual machines across multiple servers to balance load and make sure that every server has spare capacity to handle all the virtual machines assigned to it. Or the cloud provider can, pack as many virtual machines as it can on each server and then keep most of the servers powered off and only turn servers on when it needs additional capacity to run additional virtual machines. So these are two different strategies that cloud providers can use. And cloud providers can also migrate VMs. So in this example, we have 3 servers running 4 virtual machines. So this customer A in blue and customer B in green. And we have these 3 servers with 4 virtual machines. Now, if a server fails, say server 3 fails, the cloud provider can move VM B1 to server 2, and then VM B1 will resume running very quickly. And this doesn't hurt customer B that much. Similarly, if VM A1 now requires additional resources, so it's grown in size, say it needs more memory. So now VM A1 and B2 don't quite fit on server 1. Now server 1 is a little bit overloaded. So the cloud provider can move one of the virtual machines to another server. For example, it can take virtual machine B2, move it to server 2, and now all the virtual machines are happy again. They're running on servers that are not overloaded. Now, virtualization is also great for customers. A virtual machine is mostly equivalent to a physical server. So when you get a virtual machine, you have complete control over some of the hardware. For example, you might be able to get direct access to network cards or graphical processing units to make computations like related to artificial intelligence. You have full control of the guest operating system. So this is the virtual machine running on a physical server. So the guest operating system is entirely under the control of the user. So you can install different Linux distributions, say Debian, Ubuntu, Red Hat, whatever distribution you need. You might even patch the kernel if you need, and then install this new kernel on a virtual machine, and then reboot the virtual machine and it has a customized kernel. So that's okay as well. You can run Windows on the virtual machine if you want. And then of course, tenants, cloud customers also have full control of the applications that they run on their virtual machines. And virtual machines can communicate with the rest of the internet, and then they can serve users anywhere. So the virtual machine is running on a physical server and it communicates with the rest of the world through the internet just as a server would. Now, virtualization and virtual machines, containers, provide lots of benefits to customers. One of them is the ease of creating and deploying new services. So as soon as a customer develops new software, it can easily deploy this software on the cloud. So it's very quickly, just create a VM and then your new application is running and you can start testing it. So that's great. Virtualization also allows rapid scaling of a service. So if you have an application running and a lot of users come along, you can quickly spawn new virtual machines and serve the users that are just arriving at your application. And virtualization also allows safe and rapid testing of new software. So if you upgrade your software, you make some changes and you want to test it before you deploy, you can rent some virtual machines temporarily to test the new version of the software before you put it into production. So these flexibilities also help customers deploy their applications and manage them.